Andy Andrea has a decade of experience working as a Ruby developer and is currently part
all the time. For example, count versus length versus size. Additionally, sometimes different methods or classes will just differ in what errors or warnings that they raise. Some will have different side effects, might have some performance impact, might have some differences with I/O. Some things operate fully in the database. Some things operate fully in memory. Some things are smart enough to know whether or not they have to operate in memory or in the database. So this often comes down to performance, but sometimes it might be more helpful to offload more work to the database. But if you've already got things loaded, then maybe operating in memory is what you want to do. Similarly, if you've seen a lot of the Ruby bang versus non-bang methods, in-place allocation versus allocating a new object, again, could come down to performance, might affect your garbage collection, might affect whether or not you've introduced some subtle bug modifying something that wasn't supposed to be modified. general catch-all of performance. The past couple have been performance related, but in very specific niches. There are plenty of other things that differ in performance for other reasons than the database, memory, etc. And last, I didn't really know what to call this, so I just called it general usage. This often comes down to return values, might be semantics. How you use something might differ between two little things. There's also, of course, linter rules. I'm not going to get into those because there are way too many different configs that we might run into, tons of linters out there. I'll also note that I am not covering any aliases, any things that are exactly the same in this talk, just things that are at least a little bit different. All right, so now that we've covered a couple ways in which we might differentiate some of the thises or that's, we're going to start with a pretty simple example relative to the others at least, which are the cover and the include methods that we have access to on the range class. And so right off the bat, I'll tell you that looking at those differentiators that we talked about earlier, we've got a couple here that are in effect for these two methods. So first off, include is a little bit older, but one of the reasons that I wanted to include this right off the bat is because it kind of shows that this probably doesn't matter to most of us. There are, I'm sure, some Ruby 1.7 or earlier apps that are still out there, but hopefully most of us are not having to deal with that on a day-to-day basis. So even though they are different, this shouldn't really be something that affects our decisions in choosing one over the other unless we know that we're working on a very old version of Ruby. So there are going to be some benchmarks in this talk. All of them are using Ruby 3.3.0. Didn't get the chance to upgrade to 3.3.1 in time. Benchmark IPS and the MacBook that I am presenting on today might be a little bit different if you're using a different version of Ruby, different computer. So if we look at range cover, range include, using the range a.z, so all the letters A through Z, we can see there is a bit of a difference. Cover is about twice as fast, but again, we can see the number of iterations per second is really, really high. So for this, it probably doesn't matter to us too much unless we know that we're really trying to eke out every little bit of performance that we can get. However, if we change our range to a.quadruple Z, it's a pretty big difference. Only 27.7 iterations per second for include and a heck of a lot for cover. So this is starting to show maybe a compelling example of if we have a really big range, maybe we would want to use cover to detect if something is in our range or not over include. However, when we get to that general usage side of things, if we start with a good old numeric range, then we can see, okay, they seem to be the same. They both say for something that is in between the start and the end, that's true. If it's outside of the range, it's false. That's great. Okay, equivalent. So we're still kind of seeing that really possibly compelling performance as our one main differentiator. But as soon as we go away from numeric ranges and move to non-numeric ranges, like with strings, we can see one little difference. And that is that with the cover method, 1.5 says that it covers 40. Numerically, this is not true. But if we're thinking of it in terms of like a dictionary and we use an actual string, we think about maybe if we had the range n.z in the dictionary, that would cover the word yellow because that comes in the Y section of the dictionary, even though there is not actually yellow in between N through Z in our range itself. So this is fairly important. I think in most of the cases that I've run into, I really want to know, is it actually a member of the range? Not, is it kind of just covered by the beginning and the end of the range? So this might now be the most compelling differentiator that we have. And now when we look at the errors that either might raise, we can see with a beginningless or endless range, include might raise a type error. So this can be important to know about if we're working with beginless or endless ranges. Meanwhile, the same ranges with cover work properly. They give us back a Boolean. So another good differentiator for us. And this comes down to the fact that cover just looks at the beginning and the end of the range. It doesn't actually convert the range to an array and build up all of the individual members, whereas include does, which is part of the reason for the performance. All right, so again, we saw a couple of these different differentiators for these methods. And there are a couple of things that we didn't look at if we wanted to be very, very exhaustive. We just looked at strings and integers, but there are a bunch of other classes that we can make ranges with. All right, example number 2, regular expression matching. So we have quite a few different options for looking at regular expressions. When I started working with Ruby, it was in the 2.2 days, and I remember really just wanting something that would give me back a Boolean, not any of this 0 versus nil versus 1 nonsense. And so when Ruby 2.4 came out, I was very, very excited about the match question mark method. But again, most of us are hopefully on Ruby 3 or at the very least 2.7. So hopefully this differentiator of the Ruby version won't matter to us too much. Now, when we look at all of their return values, we can see they're somewhat different. We might get match data, we might get an index, we might get a Boolean, maybe we even get an array. So that's kind of where our general usage, our semantics is really important. What do we actually want and need when we do this match? But the other thing that's kind of interesting about all of these is the side effects column. So we've got all, we've got global variables, we've got none, and we're going to look at what those mean in a little bit. Going back to our benchmarking, if we have a regular expression that's got a bunch of capture groups meant to capture different parts of a URI, and then we have the RailsConf schedule link, if we look at the different options, our match, our equals tilde, etc., we can see that there's some differences. Match question mark seems to be a good bit faster, scan a fair bit slower than the others, but again, still quite a few number of iterations per second. So hopefully won't matter too much to the overall performance of our application. And what's interesting here is that you can see the one that is fastest is the one that had the least side effects. So getting back to those side effects, if we have this same regular expression and same string, there's something that Ruby has inherited from Perl that some of us may or may not know about, which are all of these weird global variables that get set when we do our regular expression matching. So every single one of the methods that I've shown so far, aside from the match question mark method, will set these global variables behind the scenes when they run. And these are just the last match, different capture groups, different portions of the string that matched, etc. And you can use these in your code. They will change every time a regular expression match happens, so do be aware of that. And personally, I don't find them the most readable. I don't know that $, single quote tells me instantly substring right of match. So definitely be careful when introducing this to your code base with people that you like to work with. All right, so we covered the global variables, but we said that with equals tilde, there was all, not just global variables. And so to look at the different side effects that come into play with this method, we can just look at a very simple regular expression, just basically one big old capture group that puts the entire string in the capture group, calls that capture group match. Very similar line of code. The only difference is that we're setting the regular expression to a variable first, and then we're doing the match. Or the same thing as the first one, but we've swapped the order. So it's the string, then the regular expression. And these will do the same match, but they will not all have the same side effects. And so if we start at the bottom and we run that code, it works, it runs. You can see I'm at the very beginning, fresh Rails console 001, 002, and naturally when we just reference some unknown match variable, it doesn't work. It's an undefined local variable. Same thing happens when we've set our regular expression to a variable and then done the match. But when it's all one line with the regular expression on the left it will set local variables matching your capture groups. So one, this is a little bit of extra work that happens under the scene or behind the scenes. But two, what I think is most important is if you have code where you have a regular expression and it has a capture group that happens to line up with an existing local variable, that local variable is going to be overwritten by whatever's in the capture group. And that can be a really subtle bug that can be kind of hard to track down and very hard to understand. There's documentation on all of these different things, including the various global method or the global variables that aren't related to regular expression matching in Ruby. There are a number of additional ones there. All right, this will be another fairly quick one, no method error versus not implemented error. No method error is probably one of the most familiar errors we have as Rails devs, as Ruby devs. If you have upcase that you've called on nil because you thought your variable was always going to be a string, I've certainly never done that myself. This is what you get. Very common. Not implemented error, if you look at the documentation, says that it's raised when a feature isn't supported by your current platform. So if you have some system call that's not supported in your operating system, for example, not implemented error is what you would get raised. However, in the community, people use this for another reason. They use it as a way to sort of mock out the idea of an interface that some of us might be familiar with from, say, Java, where you would have a class that implements an interface. So you might have a module that has a bunch of methods, and they all just raise not implemented error as a way to tell your future coworkers and your future selves that, hey, something's going to inherit from this, something's going to include this, and they should all remember to implement these methods. Now, if we have just some very simple methods that just raise our different methods, no method error, not implemented error, and then have our good old bear rescue, we would expect, in most cases, that we would get the string in our rescue statement from these two methods. And when we call rescue no method error, we do get that string. However, when we call rescue not implemented error, it wasn't actually rescued. And that is because not implemented error, unlike most other errors that we work with, is not a standard error. It's a script error, and script error inherits directly from exception. So if you have your base just rescue, bare rescue, or if you're explicitly rescuing standard error, you won't rescue not implemented error. And so it comes down to the question, is it safe to use? Do we want to have some kind of special case for rescuing the specific error? Do we want to be rescuing exception? Probably not, because then weird things are going to happen when we try to quit our application. Some people are pretty divided on this. Some people say never use it in this way, just make your own new method class that inherits from standard error. But I will say that I think you're in pretty good company if you do use it in this way, because Rails uses it this way. Okay. Another one, monkey patching define method class eval. So if you have some gem, say, and maybe it's not terribly actively maintained, or you don't expect that a PR that for a feature that you might want in that gem to get merged in on the timeline that you need, you might have to throw in some kind of initializer or some code that adds a new method to some class that you've inherited from some gem or some library. And so you have a couple ways that you can do this. The most common, in my experience, is monkey patching. You just open the class back up, and then you define a method on it. This is your yearly reminder that emoji are valid method names in Ruby. So you could add your monkey method that just returns a hard-coded symbol if you need it. Similarly, if you want to go the define method route, looks quite the same. You're using a block. You're not opening the class. It works in the same way. Or you could use class eval to open the class back up, but now you're in the context of a block, so Rubocop might yell at you about constants if you've got a constant in there because of scoping issues. And these all work. They have their little niches, and that's good. We might expect them to be pretty similar in terms of performance, and really they are, but they're noticeably different. I was pretty surprised to see monkey patching at the bottom here because I think of that as kind of the default, and I tend to think of the default as almost one of the more faster options. But Again, you can see very high number of iterations per second, and I wouldn't expect that you're dynamically monkey patching in your application code. It's probably something that just happens once on boot. So hopefully, again, this doesn't really matter. So I went ahead and, since I thought that was a little counterintuitive, I made a really nice chart. Basically learned CSS for this. It was very, very well done, I think. So you've got monkey patching there at the top, class of L at the bottom. But surprise, surprise, this work of art does not exactly paint the full picture. And there is a difference from what we saw in calling class of L, calling your define method, using the monkey patch. When you actually look at calling the methods that you have now defined, the performance is a little different. So class of L and monkey patching are now basically equivalent. Methods defined via define method will call a little bit more slowly inherently due to some lookup stuff that I honestly don't know terribly well off the top of my head. But this, again, is something that hopefully will not really matter to us, but I think is a really good example for these little edge cases in which these things might differ in ways that we wouldn't necessarily expect. Now, this is the big ol' list of things. If we want to define a method that just forwards on to some other thing that already exists, we've got a lot of options. And so we have our active support delegate method. This is the one that I've seen the most commonly in production code. That one, we do need active support in order to use it. So if we're writing some simple Ruby script, we might not have access to it. On the Ruby side, we have these 5 others: simple delegator, delegate class. You can use method missing as a way to delegate, even though that's not necessarily the full intent of it. And then there's also the forwardable library in Ruby. So if you're writing a script, you might just have to throw in a require forwardable, and then you have def delegator and def delegators. And this distinction of global versus targeted, this is my own terminology. This isn't something that you'll likely find if you Google. But what I mean by this is global delegations are something that by default, anything that gets passed along will get delegated to whatever you're delegating to. You don't have to specifically allow list a bunch of methods. Whereas for targeted delegation, you are explicitly saying, I want to delegate this method, I want to delegate that method, etc. And quick usage example, if you want to use simple delegator, you inherit from it. So you just have your basic inherit symbol and then simple delegator. If you want to define methods on the wrapper class, you can, and those will take precedence. So toParam will not be delegated. And if we look at a bunch of different examples, we can see, look, we can call upcase if we're wrapping a string. We can call the toParam that we've defined. It does say that it responds to the methods that the string we're wrapping responds to. But when you look at the string wrappers list of instance methods, you don't see what comes from string. Probably not something that really matters to our production code too much, but kind of interesting to know for debugging purposes. Delegate class is very, very similar. The only difference there being that you're specifically passing in a class to delegate class that says, this is what I'm always going to be wrapping. And this works very similar. But now, because we've given it that information about the string, it does know the methods that it gets from the string class that it can delegate. Method missing, we're no longer inheriting, we're defining method missing, we're defining respond to missing, and we're just forwarding things along. Pretty simple usage. And it works. We don't have the methods in our methods or instance methods array, but otherwise the respond to works, toParam works, upcase works. Def delegators, we're moving out of the global delegations into the targeted ones. And we can just say, hey, we want to delegate to our string instance variable, and these are the methods we want to delegate. Again, it works. We can see those methods explicitly defined there. Def delegator difference is that we can only pass one method at a time, but this is our only way of giving our delegated methods an arbitrary name of our choosing, which is kind of handy. And so if we wanted to delegate upcase, but have it called on our string wrapper as upper, we can do that. And it works. And then last but certainly not least, our active support delegate. Kind of similar to the last couple, we can delegate a bunch of methods at once. We're saying what we're delegating to. We can give it a prefix if we want a little bit of customization in the name, but not quite as much customization as def delegator. And again, it works. And I decided to look into delegate a little bit more to see what we could all delegate to. I'm kind of used to just delegating to a method personally, but you can delegate to a constant. This is called out in the documentation. Kind of cool. And you can also delegate to an instance variable, just like we saw with def delegator. And I was curious. These were the only examples that I could find of people using delegation. Instance variables, methods, constants. But I thought maybe there's some weird things we could be doing. So I looked at the source, and this is one of the branches in the delegation source. And it looks pretty simple. We're just defining a method, and then we have our receiver, and then we're just doing dot method, passing it some params. And so I thought, okay, this almost looks too easy, but I wonder if we can hard code a string. And we can. We can delegate to a hard-coded string as long as we double wrap it in quotes. We can delegate to a hard-coded array as long as it's in quotes. We can delegate to random code if you want to get the 2s from a random UUID. You can do that. You can put in myclass.new.whatever, and it will delegate right along. Very interesting. I did not think you could do this. I think it's really cool that you can. But we're not done yet. Something even cooler and much worse that we can do is we can put a lambda in a string. We can delegate the call method to it with delegate or def delegator, and with def delegator, we can name it whatever we want. So we can use this to just define an arbitrary method. We could put anything in that lambda string if we wanted to, and as long as we delegate call to it, it calls the lambda, and then we can name it whatever we want. So really, this kind of reminded me of the previous topic. And look at this. We've got def delegator for defining a new method on a class. Nailed it. Perfect. However, when we look at the performance of this, it is awful. 146 times slower than our good friend class eval. And when we're calling the method, it's almost 7 times slower through that delegation. So really, our chart should probably look more like this. All right, similar to our first cover versus include, there are a lot of things that we didn't look at in this talk. Performance when defining between the normal ways that you might do it, edge cases, etc. All right, so we talked about a bunch of differentiators at the beginning of the talk, but there's one that's pretty important that I didn't cover, and I'm calling this degree of WAT just to call back to everyone's favorite 5-minute Ruby talk, but really you could call this maintainability, readability, kindness, and in honor of this, we're going to look at one more example, which is how to call a method in Ruby. So we have our good old-fashioned dot syntax, but if we think to ourselves, wow, this is boring, this is too easy, we can, of course, use our send method, and that's great until Rubocop yells at us, and so then we change it to public send, and then we realize, actually, we do need to call some private method, so then we use this weird thing that I only know about because Rubocop yells at me, and it works. Great. It's very funny to me that, of course, we're now just starting to introduce dots to avoid the dot in some ways. But it works, all good. The one that I think surprises a lot of people that I've actually come across in some old code is what I think of as the namespace resolution operator. This works. It calls the method. And if you think that's too normal for you, then you can just add some random spaces around it, just like you could with dot syntax. I have actually seen some old discussions, blog posts, and such, that there used to be some norms where people would explicitly use the double colon to denote I'm calling a class method, and then use dot syntax for denoting I'm calling an instance method. I haven't seen that, and I haven't seen references to it in things I found in, say, the last decade or so, so I don't expect it's very common, but like me, you might run into it in some older code. And then, of course, we can go through the method. This is where the word method is going to lose all meaning to us in this talk, but you can get the method, you can call it, great, but if you say, wow, call, that's 4 whole characters, that's so long. You could do dot parens, which I would guess is something that you can probably do in Ruby elsewhere. I did not quite figure it out, but if you say, I don't like parens, they're too smooth, I prefer angles, you can use dot brackets. And even weirder, in my opinion, is the method triple equals method. Again, the word method so much. So if you had something that took an argument, you could do, say, array.method join, and then your normal not dot syntax of just triple equals, and then like the comma string. It looks like you're checking for equality, but really what you're doing is you're calling the method and passing it what you seem to be checking the equality of. Might be handy in some case statement somewhere, but this one kind of makes me scratch my head a bit. We have our good old instance eval, where we can call upcase within the context of our string. And for once in going through this talk, I did not forget, oh no, I forgot about this one now. There's symbol to proc. If you say, hey, I really care about the method call and not the string, I want it up front and center, you can call symbol to proc, only on symbol, not on string, and then you pass the string as the argument. And then now, actually the last one, I hope, yeah, good old eval. If we just want to treat any Ruby string as Ruby code, we can eval it. And we can see some differences. Poor old eval there at the bottom, 221 times slower. The first time I ran this benchmark, I saw the double colon with spaces around it was at the top, and I was momentarily terrified that it was actually the fastest way to call a method in Ruby. But fortunately, the dot syntax and the colon syntax are basically the same. But again, aside from eval, all pretty darn fast. So going back to the beginning of our talk, I promised you some bad code. And so this will be the worst way that you could possibly ever upcase a string in Ruby, maybe. There's no like 0 with spaces or anything. But first off, if we want to upcase a string, we'll probably want to define a variable so it's not just some magic string hanging out. And so let's define our variable using that weird side effect of the equals tilde method. If we want to define our variable x and we want to set it to the string wet, there you go. Clear enough, right? There it is. And then we know upcase is our method, so we need some reference to that. And so we can do some more regular expression matching and then use our good old global variables, call the method and pass it method, and then call that method with brackets and pass it join and then triple equals it. And now we have the string upcase. Perfect. But really, this is too good. This is too normal. So, oh, and then of course we call it. Let's just throw in some random spaces there to make it hard to read. And then let's make it a little worse. Wrap it in an eval. Use a here doc because here docs are weird, specifically when you have spaces in the delimiter. And then let's call a useless strip on it because I always think it's weird that that's where you put the method call on a here doc. And here we go. We have successfully upcased our string, and I will give you proof output from my terminal. There's our upcase string. Nailed it. And when we do our final benchmark of the talk, we can see that it is only 281 times slower than just calling upcase. Thank you, I think. Okay, so that is basically the end of the talk. If you want to see more thises or that's, look at your linters. There's the Fast Ruby repo inspired by a talk from, I think, Rails or RubyConf years ago. If you look at it, be careful, notice what version of Ruby they're using, notice information on their machine, and definitely look at the benchmarks. Don't just blindly, of course, see this seems to be faster. And I mentioned at the beginning of the talk, with all of those 80 things, that I've got some resources for you all. So I made a repo, and I've got all these slides. On all these slides, there's one for every single one of those bullets that I breezed through at the beginning. If you want to share this with anyone new to Ruby, any mentees, there were some cases where I didn't find a single source that really felt like it covered it. So I included a couple. There were a few where I thought there was, this little thing that I know that I can't find any evidence of or reference to online, so I just wrote it out manually. If you know of anything that's not in this list, throw me a PR in the repo, send me a message on Slack. I would love to keep this up to date, keep this a good resource for the community. And that is it. Thank you all for coming. I'll hang out here if anyone has any questions or just wants to chat. But hope you enjoy your, what's that? The address is not actually on there, but I'm going to put it in Slack in addition to the slides. Yeah. All right. Thank you, everyone.